Good morning, everyone. Everyone had the coffee? No. Get some coffee. I don't want to sleep. So, thank you for coming to this session. I'm Anand Banglaore. I am a test practice lead at ThoughtWorks. I've been in the testing field for 17, 18 years now in various different forms of testing. And I have some contact information listed earlier in case if you want to make a note and reach out later. I'll also display the same later on towards the end. But this is not really about me, right? The topic is how can you enable continuous delivery in enterprises using testing, with testing. Okay? So, to make sure that you guys are not sleeping or not going to fall asleep, I'm going to be asking a lot of questions. What are you expecting from this session? The most basic one. Anyone? No expectations? Nirvana state. Why are you in this particular talk? What are you hoping to learn, prove, write, learn more of? Okay, great thought. Question is, she is looking to see if performance engineering can be brought early on into the development cycle to enable quicker deliveries. Okay. Anyone else?
How to actually leverage continuous delivery, do a continuous delivery for testing in a medical industry, like medical devices industry.
Okay.
We need to follow certain standards and stuff in all these continuous delivery will not play a greater role.
Sure.
Can we leverage this?
Okay, so the question for benefit of others is how can we leverage, if at all, continuous delivery in medical domain, in medical devices more specifically than the domain. Okay? So, answer to your question is we won't be talking directly about that, but hopefully it will give you some glimpse of what can potentially be done or not for that matter. Performance engineering, we'll be talking about certain elements of that, but not that as a specific area of focus for sure. Okay? That said, everyone is wrong what they're expecting this to be about. This is about a magic show proving a triangle to be a pentagon. Is it possible? Anything is possible. 2 plus 2 is 5. And we are going to prove that. Okay? No illusions, no hypnosis anywhere, so rest assured. But let's go on this journey and find out what this is about. So, before we get into the case study where I'm going to talk about a particular scenario and explain how testing can help in continuous delivery, let's talk about a few basic principles, practices to make sure we are starting off on the right foot. So what is one of the practices that makes teams successful? One of the practices, there are hundreds of practices, right? Anyone? Sorry? Any practice of software development and delivery? So that's a good question actually, know exactly what you're doing. That is a good point. But what else?
Taking various roles.
Various roles? Okay, so polyscaling of sorts. Okay.
Doing agile.
Okay, so agile as a methodology which gets principles and then a set of practices following that. What else? Can we get more specific? Continuous integration, yes. I'm looking for a specific answer. I can spend all 45 minutes waiting for that answer. So you guys have to help me move along. So you're on the right track. Continuous integration in certain ways, but we need more specific. Sorry? Feedback in what forms? Okay, fair point. You look like you have something on the tip of your tongue. Yeah. But what enables it? One of the things. Oh, never mind, you guys didn't have coffee, you don't know the answer. It is test automation. It's one of the practices I'm saying, okay? Not the practice, it's one of the practices. To enable continuous integration, quick feedback, continuous delivery, performance engineering, various aspects, right? One of the practices is automation, which makes teams successful. Let's go on the other side. One of the practices which makes teams unsuccessful, very easy to flip the coin. Sorry? No test automation. That's completely not what I expect. It is test automation. So test automation can make the team successful, it can make the teams unsuccessful. Why? Solve the wrong problem. Design poorly. Limit what? Limit ourselves to the scripts, and we think that is the holy grail. If that script is passing, everything is passing, right? Various reasons. Bottom line is, test automation is code. It has to be designed in that fashion, treated with that respect. Only then it will give the kind of response and feedback to the teams that will make it successful or not successful. And all these aspects you spoke about are parts of making that successful or determining if it is not. So what really is test automation? Making your life easier in what way? Faster regression of functionality. Yeah.
Efficiency.
In what way?
Time.
Again, it's faster, so it's tied to the same thing.
Repeatability or complexity.
Repeatability, that's an important aspect. But what does it really do for you? Sorry, what about manual? So you're saving on the manual, repeated, boring kind of efforts, which becomes error prone eventually. We are humans, right? We are trying to reduce that. So if you try to equate that with what really automation is, it is nothing but a safety net for the team. A safety net, if those who have done fishing or know about fishing, a net, fishing net, you would use the grid size, the net size, based on what type of fish you want to catch. You wouldn't use a fishing net with wide grid to catch small fish. Fishes are going to escape. Likewise, doesn't make sense to use a grid with very small or net with very small grid size to catch big fish. It's not required. You'll catch a lot of noise in that, which is not your intent. You have to filter through a lot of that junk in that sense, right? So automation is a safety net. What is the kind of feedback you are expecting as a team for potential issues? You need to design your automation based on that. You need to identify or test your intent, what is to be validated based on that. It is very important aspect. How many of us have heard about a test automation pyramid? Raise your hands, it's early, we can move around. Anyone has heard about the automation pyramid? I can see some shakes, some nods. Let's say you have not, for that matter. Benefit of doubt. Okay? Can we get some coffee for everyone? So the test automation pyramid was a concept introduced by Mike Cohn in his book Succeeding with Agile a long time ago. Martin Fowler, one of the founding fathers of the Agile Manifesto, has blogged in very simple, beautiful terms. That's a great skill he has to explain what the test automation pyramid is. I'm going to take 1% of that explanation and try to put that concept out for everyone. What the pyramid says, pyramid by definition, is a triangle, equilateral triangle, right? The base of the pyramid is wide, the tip is pretty lean in that sense. What the pyramid says, there are various different types of tests you can have for your product that you are validating against, that you're building for that matter. And these types of tests can be of different forms: unit, integration, JavaScript, view tests, web service tests, UI tests. There could be various forms of tests depending on the type of product you are testing. If the product does not have a UI interface, there is no UI test, it's fine. It's a representational thing. But what this means is that these are all tests that you would want to automate in terms to get the quick feedback for the team, right? Also, what it means is you can focus with the correct amount of automation effort, you you can focus on the right type of manual and exploratory testing on the system, because not everything can be or should be automated in that perspective, right? If you think about, if you get limited, as we heard earlier, limited by the type of scripts we automate, issues are still going to flow through. Look and feel kind of thing, gut feel kind of scenarios or test cases, we have to validate manually in exploratory fashion, different combinations, different scenarios, to make sure the complete picture is well known to us. Okay? Now, what the pyramid also indicates is 3 arrows going up. Can anyone guess what it means?
Risk.
Sorry?
Risk.
Risk in what terms?
Like getting out more funds.
Interesting dimension, but no, that's not what the test automation pyramid indicates.
The complexity.
In what ways? That's debatable, because again it is very context based on the product and the technology stack that you're using to do all that automation. Okay? So there are 3 things that happens on a test automation pyramid over time, or for any SDLC cycle. Cost increases, time, the value of those tests, that is changing, and the time taken to execute those tests is changing. What this means is, and I'm not going to get into too much detail about this, I'll be talking more about the pyramid tomorrow in my talk, to deploy or not to deploy. But in a nutshell, what this means is, as you go from bottom of the pyramid to top of the pyramid, the cost required to build those unit tests or implement those tests keeps on growing up. Why? Because unit tests are validating granular pieces of product functionality. As you keep going up the pyramid, you have to get more and more of the product built and compiled and deployed or installed in specific environments with specific integration points, database, so many things, in order to get to the top level of UI testing. Okay? So time, value, cost, and value again, it comes in terms of effort and various other dimensions, right? I've simplified it over here. But that's what the pyramid really says. If you look at reality though, things are very different. And I want you to introspect without closing your eyes, since you've not had coffee again. What really is happening on your products? When I look at it, based on my past experiences, based on my colleagues and friends' experiences, I see 2 typical anti-patterns come out of the pyramid implementation. The first one is very well documented. A very close friend, a colleague, he's documented, Alistair Scott, he's documented the ice cream cone anti-pattern. Can anyone guess what that is? Ice cream cone. It's a cone. Means the pyramid is inverted. What does it mean? We've got the same type of test, but look at the number of tests that should be there to make the automation effective. We've got least number of unit tests, a little more integration, little more JavaScript, little more Vue, little more web service, a lot of UI. How many of us are in this situation where we've got a lot of UI tests, very less unit test coverage? Anyone been through those situations? What happens with those kind of tests? UI tests.
There's a lot of time in UI testing. What issues come up, there's cost of fixing those.
Right? So the cost, if we equate it to the earlier manifestations of the pyramid or where you automate, it starts becoming obvious. As a result, what happens in your teams? Because of the cost and the issues that come up, what happens? That's a potential way to solve the problem, right? Reduce the number of tests. Time to delivery increases. Is that really possible? Would you tell your business owner or product owner that, sorry, we're going to need more time because our tests are flaky? Our tests are not giving the right results. So as a result, what happens? You end up spending much more effort in manual testing, even though you have invested so much in automation, UI automation, because it's not giving the right feedback. Right feedback in the right amount of time. Okay? That is one classic anti-pattern. It becomes an ice cream cone. The cone is the automation and the ice cream is overflowing. The more you keep it around, the ice cream starts melting and flowing all the way around. Eventually the cone disappears, it just melts away. It's just manual testing remaining. One anti-pattern. Okay? Second one, I call it the dual test pyramid anti-pattern. There are two pyramids. What would that potentially mean? It's the same product that is being tested, just to make it explicit. So that becomes a three-way split in that matter. That's another anti-pattern, interesting idea. But no. So testing is still, so essentially what happens is a developer's test pyramid and a QA team test pyramid. QA team is doing automation and manual testing. Developers are doing a lot of automation, and I'm saying not, it is subjective. Each of these could be an ice cream cone for that matter, or whatever shape, doesn't matter. The point is there are two distinct set of automation activities happening. As a result, what happens? Potential duplication. Yeah? So there's a divide between the two, right? This wall was not here, now it's there. I want to know, who is on the other side. I have to go all the way around if I'm interested, genuinely interested, and not lazy to do that. Right? Same thing happens. We are throwing things over the wall. No idea who's doing what. Duplication, as Rao rightly said. That's one thing. I can potentially live with duplication though. What I cannot live with is scenarios getting missed out being automated. Because even that one scenario being missed out might be so critical enough in that edge case scenario, which can cause a lot of damage to my business, to my product, to my reputation. Can anyone relate to this? How many of us work in separate testing organizations with very limited collaboration with developers? By choice or not, doesn't matter. But the manifestation is that with lack of collaboration, it's not about physically where you're seated, is it the same table or not. It's a lack of collaboration causes this divide, which causes a lot of other problems. Right? Enough said about the pyramid. Continuous integration. What does it mean? Sorry? Build testing process.
Impact of developers making a change to the system. What is the impact on other components of the
Right? So impact what changes a developer makes to the system on other components or other team members for that matter, or functionality, various different aspects with that. Pretty spot on. So again, taken from Martin Fowler's blog, a very small snippet. Each integration is verified by an automated build, including test. Very important aspect. It's not just building of code, including test to detect integration errors as quickly as possible. Everyone, I guess, would be using CI, right? Anyone not using CI? I asked the right question this time, less number of hands. Okay? So thankfully, everyone is using CI. Okay? What does it really mean? So if I've got a team which is spread out in various different forms, we could have a developer who's sitting on his machine checking in code, which gets into a subversion system of sort, some source control system rather, and the code gets built and tests get run over. And likewise for each developer, or even if you're working in pairs for that matter, whatever form of communication or teams that you have, or team structure you have, everyone is checking in code. Whenever that checking process happens, code gets built, compiled, and we see the information out from it. Let's take it to the next level. What is continuous delivery in that case?
After all the tests, you are at the stage where you ship to production. Or a semi-production.
Okay, Nirvana state, right? All tests run, everything works fine, push it to production. You were saying something. A demoable product. Okay, pretty much related. I would break down a production in different forms, but eventual goal is yes, once my tests are run, I should be confident to say yes, I can proceed to the next stage. Okay, so again, a quick snippet from Martin's blog, and I think this is very interesting because if we consider this a holy Bible of sorts, right, or the holy grail of sorts, what continuous delivery should be, I have to make my releases boring. To make the release process boring, I have to do a lot of things to say that I can deliver quickly, frequently, get the quick feedback of what users care about. That boring aspect is, I think, very cleverly put. And Aman can add more context because he's been in this journey since a long time again. But the boring aspect is very, you can talk at great lengths about that. Typically we say, I need to make my work more interesting. Over here we are saying we need to make the release process boring. Our eventual goal of doing testing or development is to do a release. If we make that aspect boring, how are we really going to work? What is going to motivate us to do better? Interesting things to think about. Okay?
Can I ask a question?
Yeah.
So you asked a question earlier, how many of us use continuous integration?
Mm-hmm.
I think the question is, how many of us are, for example, using Jenkins, and is using Jenkins same as continuous integration?
Fair question. It's a great idea for the next talk.
Because 15-20 minutes or 30 minutes runtime is suggested for continuous integration. How many of us have that kind of a test cycle?
So Rahul is saying a 15-20 minutes kind of test cycle is,
Whenever a developer checks
yeah,
the code,
if it takes that much time, that should be the max time is what you're saying, right?
that's suggested.
Yeah, suggested time. Again, if you look at ThoughtWorks, developers would say anything more than 2 minutes, I'm wasting too much time. It's very context-based. I agree you're saying about a suggested upper limit, but it's about what the team, what practices you're really following, and that 15-20 minutes of test time, what are the different types of tests involved in, right? So a lot of thought needs to go around this to make it as less as possible, parallelize it, distribute it. But as I said, maybe we'll hear Rahul talk about it next time, or if he doesn't, I'll put a talk for it next time. But very important aspect. Continuous delivery, you look in a pictorial format, you take a business idea, design it, deliver it as quickly as possible, get it in front of the customer, get validation. Is this what they're expecting or not? And then you keep on cycling around, keep on repeating the process to add more and more features in that way. Okay? Enough said about concepts. This is about the case study and how we can make what we need to do from a testing perspective to help enable continuous delivery. Now, I am explicitly calling it in enterprises because it's smaller projects, and again, this is very subjective to individuals, what is small, what is medium, what is large. But in enterprises, the complexities are huge, okay? And that is what I want to talk about here in form of a core banking implementation. Anyone from a banking domain over here? Okay. Don't beat me up if I talk wrong about the banking domain. But it's, you guys know what complexities exist in the banking domain. Likewise, in any mission critical system, medical devices, huge complexity. Not saying a simple e-commerce site is less complex. The kind of value it is delivering at the end, it's different. An e-commerce site I can get up and running maybe in a month's time with basic features. For a core banking, this core banking implementation that we are talking about, the journey is about 7 years in an agile fashion with incremental delivery. That's the complexity we are talking about. Okay? What is the objective of any organization? Quality delivery, money, customer satisfaction, time, all of that, right? Exactly spot on. Organization needs to make money. They have to provide value. By money, it's a very loose term in this sense, right? If it is actual value proposition that organization is going out to its customer base for, fair, but that is a value proposition. Time. If that value proposition doesn't go out in a good time to market, organization is not going to get anything out of it. Or the customers will not get any value out of it. And even if you balance those two, if it's not of good quality, what's the use? So all these three go hand in hand for any organization, which is the same case for this bank that I'm talking about. Okay? Distribution of fragmentation in organizations is a reality. Various reasons for it: globalization, the cost factor, 24/7, the team sizes, mergers and acquisitions, and of course a talent pool. There could be various other reasons, but organizations are fragmented as a result, right? With the objectives of the organization and this kind of fragmentation and distribution, it becomes even more challenging. Okay? In the scope of a core banking implementation for the bank, they already have a legacy system in place, or old system, I'm going to try hard not to take any names about systems because it's internal, of course. But there is an existing system that they have. Something messed up with my slides over here. Okay. So there's an existing system, a core banking platform that the bank has, and there are a lot of other existing systems in the bank which sit on top of it. It could be internet banking or various others, right? Other systems in the bank which sit on the core banking platform. And there are external systems like, let's say, payment gateways, for example, credit card systems which might be a separate entity of sorts, compliance organizations which might be a government organization separate of sorts, right? So there are a lot of these systems, and this spiderweb is really with that intent that there's so much tight integration across all of these. Okay? The goal for this program was to replace the legacy system and use a new product offering which will allow them to introduce new products in the market better, adjust to the market needs better, and much more quickly for that matter. That was the whole scope of the program. So what it meant was they bought a core banking product from some large vendor, and of course it's a generic product, I cannot use it directly, I have to customize it to suit to my needs, configure it, customize it, various different things. At the same time, I need to also integrate with other systems in the bank and external systems in whatever spiderweb format that I have already in place. Okay? The scope is getting clear? Now, the other complexity is, this is not a big bang approach. It's not at the end of 5 years or 7 years, I'm going to flip a switch and say, okay, now everyone is moved into the new system. It has to happen in a phased fashion. What does it mean? Some system of the existing old product will be deprecated, something new will be used in its place from this old platform, while others continue to exist over there, feature by feature or whatever that form might be. As a result, what happens? Suddenly, instead of replacing old system, you are supporting two systems, old and a new. And in phased fashion, you are slowly moving the balance from old to the new. Eventually, the old will be out of the way. But huge challenge in terms of coexistence of systems, data migration. Banking has got very complex data. How do you manage those things? Okay? Let's look at a realistic architecture view of this particular replacement. Oh, here is what happened. Okay. Now, this is what the program scope really looks like. Red is the core product, the new product that I have bought. Green is existing systems in the bank. Blue are external existing systems which I need to integrate with. There are some gray which are not affected by this change. The scope of this replacement affects so many different things. Can you guess the number of systems involved in this one? It's 130 systems and 290 interfaces. Hugely complex. Okay? With that scope in mind, we are doing agile delivery. We want to get incremental value. We want to see value of the new platform coming in and how it's going to shape up. And of course, keep doing validation as quickly as possible to ensure we avoid last minute surprises or last minute problems. So what are the execution challenges in such cases, right? The bank is not an IT organization. They may have an IT team, but it's not an IT organization. So what we have is a set of partners that the bank works with. Someone maybe who they bought the product from, someone who's going to customize it for them, those kind of things. Lot of partners. And other challenges, each of these partners come with their own way of working, their own security policies, their own constraints. How do you integrate that together to still get the delivery done on time? Stakeholders, 130 systems. Think about the number of stakeholders across. We are trying to work agile, but does everyone understand agile the same way? Someone said very nicely in one of the other conferences I went, it's about checklist driven agile, practicing agile, being agile. There's a difference. Martin again has come up with the agile fluency model. What level of agile implementation are you in? Is the organization in? But again, it's not about one organization. You're talking about your partners also involved. Huge complexity. Okay? The money. The bank has limited money. It's not the largest bank with a lot of surplus funds. They are constantly checking, is this investment worth the effort? Instead of spending X billion dollars in 0.5% or 25% of that budget, what value am I seeing? Am I seeing any return of investment? If not, I need to change strategy. And the trust. With so many different partners and the constraints, it's difficult to build trust at the same level and the transparency level to start executing. The other challenges, I spoke about coexistence, data migration from systems, the scope. With 290 interfaces, how do you identify scope to start delivering value? Do you move one interface at a time, or do you move based on business functionality? What is it? It's a big challenge to get everyone on board. Defect management, you're going across so many different systems. The new system might work well, but what if the integration system in the bank or external is not supporting that well? There's a defect. How do you manage that? Difficult. And of course, a team distribution and integration for all these different pieces to come together. NFRs, banking domain. Of course, there are going to be NFRs. Most important one, security, performance, auditability, compliance, accessibility. These are probably half the list of what was actually required as a requirement from. Okay. Distributed teams. We were working across Australia, US, China, India, and I don't know where else the partners' offices might be because it's difficult. If you're not in the front, if someone is not sitting in front of you, you don't know where they really are, right? How do you ensure code quality in such cases? Because the core team is putting in changes to subversion or source control. The customization teams who are building on top of that core product, they are doing changes. Integration and configurations are happening at the same time. There are systems team which are going to say, okay, with this new system, can I still print the checkbook in the same way? System integration comes in. And of course, NFR teams. In such large teams, not one team or set of team members can do everything. Not possible. So there are so many challenges. In the scope of this discussion, we are going to not talk about NFR teams or system teams, but we'll focus on the other aspects where testing needs to happen and how it needs to happen. So how do you really get early feedback in this kind of a system, right? A quick legend of sorts, what we are going to look at. If you look at a pyramid, I've got 5 types of colors over here. The outermost is unit test, integration test, web service test, functional UI test, and manual exploratory test. Again, representational only, just to categorize different types of tests. So, if we consider a developer on any of the streams doing some changes to the product, customizations or writing, implementing functionality in the core product, what needs to happen is the developer should be able to run all the types of tests applicable and possible on his machine before he checks in code. First requirement. Why? Because before he checks in any code to the source control system, he'll be able to get that early feedback about what is happening. Existing functionality, has anything changed or broken in that? Yes, let me just change it right now. Now that said, the UI test, what type of UI test will you be writing? Only what is really feasible from his machine or that dev environment. Obviously, I'm not going to have all integration set up over there, all the database set up over there. What is applicable on his machine or that dev environment, only that needs to be validated. So that becomes my first pyramid. And of course, there has to be a good amount of manual exploratory testing done on that environment before we say, yes, the code can be checked. Now in this kind of an environment, this was a reality. There was a dev environment. The next thing after the dev checks in code, it goes to a stubbed environment. Stubbed environment just takes the core product and the customizations. Everything else is stubbed out. Other bank systems, external systems, they're all stubbed out. In that can be run another set of tests. Now this could be duplicated in some ways because it makes sense to run the unit test over here as well as in the stubbed environment. But in the UI test, for example, on a dev machine, I may not want to run all my UI tests for that stubbed environment. I'll run a subset of that based on only what is required based on the changes devs have done. But in the stubbed environment, I want to run all my UI tests for the stubbed environment. Why? Again, that early feedback to the team as quickly as possible. With me so far? Yeah? Now, after a stuffed environment, we've ensured all customizations have come together properly. We get to the next stage of environment, which is the, over here also the number of UI tests has reduced for that matter, right? I don't need to run all of my UI tests, but a certain portion of them which are applicable for the stuffed environment. That is very important to know. Also, these view tests, which I may not be running over here, I will run the full suite of that over. So what are we doing? We are choosing the type of test applicable for the environment and running it as quickly as possible, not waiting for it to get to the next stage. As a result, if something goes wrong, I know right now itself. Certain tests are not applicable to be run right now, I will not run it. It's fine. But when we get to the next environment, which is semi-integrated, where now I'm integrating with my other systems in the bank, not to external to the bank, other systems in the bank, when I integrate that, then I say I do not really need to run my unit tests over here at all. I've run the same test when the code has come together. I may not need to run it at all. Right? But now, my functional tests and web service tests, I'm going to start running it more and more frequently. Okay? Then we get to the integrated environment where we've got the other systems also coming in together, external to the bank. In that case, again, I say I don't care about unit tests anymore. I've run that plenty of times before. I don't need my component tests or integration tests because I've again run that over here. What I need to focus on from an external perspective is how am I interacting with the external integration points from a web service perspective or UI, and of course manual testing, that scope keeps on widening, right? What is the reach that you have? And last but not the least, you've got a pre-prod or a UAT environment before you go live. I just want to validate what really is happening. In this case, I don't care about unit, I don't care about this. I may or may not care about some other type of tests also. But this, as a whole, has become my testing effort on that enterprise. It is not isolated to say, devs are done, I will test it now. It's about getting that early feedback, and if you have automated all the tests possible at the correct layer in the pyramid, the number of tests required to be done from manual perspective is very low. Again, very low is very subjective to the scale that you're talking about. But it's not in thousands, it may be in hundreds. It is still a big saving, and it's more effective testing. This together becomes your team's testing effort. I'm not saying a testing team's effort over here, because quality is a team responsibility. It's not a testing team responsibility. Okay? So what does this mean? We get early feedback. We need to identify environments which make sense to our enterprise or to our context. If I need 10 different types of environments of various different complexities, then I potentially need 10 different pyramid structures for each of those environments, and they come together. That's how you will get early feedback on each of those environments as you progress towards your production. Okay? The automation practices become very important. Where do you automate which test? How do you collaborate with the dev to say, hey, dev, I don't think this is a good UI test at all, because it can very easily be done by a bunch of unit tests and you'll get the feedback much more faster. How open are we to doing those and having those type of conversations? You start identifying tests based on your environment type. In a stubbed environment, this is what the test that makes sense to me. In another environment, I need to repeat the same test again, which is fine. But you start identifying and categorizing it correctly, which is so important because you don't want to run your same test in all the different environments if there is going to be no change of value in those tests. DevOps becomes very crucial in this. How do you get quickly from one environment to the other? How do I get from a stubbed environment to a semi-integrated environment, to an integrated environment? Do I have those configurations automated to just point with a few parameters what needs to change, and automatically based on the environment type, the correct type of test will run? I don't have to manually figure out or get all the test cases automated in an Excel dump and then figure out which ones to run out of it. Test consolidation becomes very important activity again over here. You cannot just keep on adding tests and hope it is going to work fine. Especially if you're working agile, tests, as the product evolves, the tests have to evolve. Else you end up with so many tests which are going to be meaningless. So they may fail a lot, but they may be failing because they're obsolete now for that matter. It's not because the product has changed or the test is wrong. Maintenance is again a very important activity that teams do not pay enough attention to. Test automation is code. We have to follow the right practices for it, and if you don't have the maintenance efforts and consolidation efforts along with it, it is not going to scale up. Test prioritization. Which ones are more important to be automated first than the other? The 80-20 rule, try follow that. The cost value analysis. Cost could be in various forms, have different parameters, value has got different parameters. Figure out the right thing for your teams and use that. Having a common repository is so important. In all my earlier diagrams you saw, I was having a common repository. The test code was not in a separate repository. Because everyone needs to contribute towards building their own individual pyramid. And the same test might run in different environments also. So how are you really going to collaborate? If I have to write a Vue test versus a JavaScript test, I should be able to go and look into those tests to see, does something already exist? Is it duplicated or not? If not, only then I will implement something. Very important. Most important, there has to be a single view. Single view, I'm saying dashboard, but a dashboard can be anything. It's source control repository, what has been automated or not, what's the status of automation of various different types. Everything should be on a single dashboard, viewable to everyone, available to everyone. Okay? So what are the takeaways that we can get out of this? Especially in Agile, there are 3 levers that teams have. Scope, time, capacity. You cannot say, and you could be anyone, business owner or a technical manager, that this is the only scope I have. If scope is fixed, something else needs to move in that fashion to balance it. In some cases, if scope is getting increased, maybe adding more people might help, but there's a limit to that. If scope still continues increasing, you have to increase time. If time is not negotiable, you have to decrease scope. It has to work in parallel. The 3 levers, they have to work in parallel together with each other. There has to be a lot of transparency in the process and the way of working. Especially in such large distributed teams, you cannot assume someone is doing something or not care what someone else is doing over there. The transparency is very important. There has to be buy-in about the process and way of working for everyone. It cannot be just forced down from top management or innovators from ground level saying that no, this is what we want to do. For large projects, it has to come in together. You have to listen to each other because there could be great ideas coming from different teams. It doesn't make sense to automate it like this. You have to do something else. Listening is important. It's not hearing, it's listening. There's a difference. You have to trust each other. If the dev tells me I've automated this, you have to get to that level of saying, if you are saying it, I accept it. I will not automate this. I won't test this. As a tester, how often do you say that? In fact, I've heard the other things around. Oh, I don't believe what the devs have done. I'll still automate it on my own. Happens. You have to be flexible because in such large scale, you have to keep on reprioritizing to make sure other teams do not get blocked or you don't get a blocker for become a blocker for someone else. Eventually, it's all about quick feedback. How can you give quick feedback about the quality of the product to the team and also take feedback from other team members about what's happening for your product area that you're working on. Quality is so important around this because the whole goal is to make it a quality product, right? And you have to learn and evolve on this and you have to innovate in order to make this happen. That said, is a triangle a pentagon? Or is it really a polygon? In the simplified case, I could come up with a pentagon because that's what made most sense to me. But you have to look into your individual context. Look into your medical device SDLC process, right? What is really happening? How can you test early? What if you change in the process will help give that feedback earlier to the team? That might help. In the performance engineering case, have that performance team ready if it's a separate team. have the performance environment ready. It may not be a real subset or identical to prod, fine. But start doing some incremental performance testing as early as possible with that subset of tests to give the feedback. Simple login test on day 1 was taking 5 seconds. After day 100, why is it taking 15 seconds? Maybe there's a valid reason, but if you don't start sooner, you will never find that out. And by simple functional testing itself, we can figure out these things. You don't have to do true performance engineering and inject code or track code in different forms to understand those things. That is essential, but not a stopper for starting early. So the goal is to start early and get quick feedback for the team. I'm sorry I went 25 seconds over. Thank you for your time. Any questions? I'll be around today and tomorrow. I don't know if you have time for Q&A, but yeah. Okay. So thank you so much for your time. I hope it was the simple math of changing a triangle into a polygon is a reality, and hope it works for you. Thanks.